Welcome to an Introduction to Limits, section 2.2 of your book. We're going to start with what a limit's purpose is, what does it do, and it simply, if you remember, finds the approaching height on a function, graphically or analytically, but the output, or what the answer is to a limit, is the approaching height. It may or may not reach that height, but again, the key thing is the approach. If we take a linear function from your past, 2x minus 3, and I wanted to analyze it. I want to analyze what's going on close to 4, both sides. So when you see the limit with x approaching, this is the input. So I'm going to say, graphically, I have a line. My y-intercept is -3, slope of 2. So at 4 on the line, from both sides, you are approaching this particular height, which is a height of 5. You can also get that by plugging the 4 into the linear function, which is 8 minus 3, to also give you 5. So these limits that we're talking about is the approaching y values. Here's a piecewise function. And this piecewise function has many pieces, and we're going to evaluate it for different inputs. We're going to start with the limit as x approaches 3 from the right. So I go on to this function f of x. I'm finding 3, going to the right of 3, jump onto the curve, and then head back towards 3. The resulting height that I'm approaching, not reaching because of that open circle, is a height of -1. That's the answer to that limit. Then I want to go back and I want to look at 3 again, this time from the left. I go to 3, go to the left, jump onto the curve, follow that curve towards the x value of 3. When I'm lined up at 3, I can see that the height I'm approaching is a height of 2. This limit is 2. For the last piece, it says the limit as x approaches 3. Notice no plus, no minus. It's like crossing the street, you look both ways. So if I look both ways, we had said coming from the right, it approached a height of -1. Coming from the left, it approached a height of 2. Those are two very, very different heights. They are not the same. So this limit is not approaching one value in particular. So we would say this limit does not exist, and use DNE because I can't be in two heights for the same x. I can't be in two places at the same time. F at -6 is pre-calc notation for a point. So when your input is -6, where are you on the graph? So if I go over here to -6, I look up and down, I find the closed circle, so that height is -1. Again, point notation for f of 1. So I go to my graph at 1, and I look up, I look down. This is an open circle, no defined value. This is part of a horizontal asymptote, which technically does not exist. It's a guiding line for the end behavior of my function. So I'm going to say this, f of 1, is undefined. The limit, however, as I approach 1, does exist. When I'm looking at the 1, and I look coming from the right and coming from the left, both sides are converging to this open circle. That means it definitely does have a limit, and the limit value is the height of this open circle, which is 2. The limit as I approach infinity is talking about end behavior on the graph. This means go way, way out to the right. What is the behavior way out right on the graph? So I'm following along as I head towards the right. I have my horizontal asymptote. It looks like the curve is approaching that asymptote, which has a height of -2. So this limit is -2. approaching -6, coming from the left. Here's -6, left of -6, jump onto the curve, follow it down to this approaching height of -1. Limit as x approaches -3. From the right, I go to -3. I go to the right, jump onto the curve, follow back towards that -3. Notice the behavior is going infinitely up. It's approaching that vertical asymptote. So how do I say it just keeps rising forever and ever? So in math, to say we are rising forever and ever, I'm going to use the notation of positive infinity. My next two are more of an analytic approach, but I have the graphs drawn to help you out. When you look at this one, the limit as x approaches 4, my input is 4, and my function is simply -3. -3, memory recall, is the function, the constant function y equals -3. So visually, this is what we have going on. Y is here at -3. It's always -3. So what's the height as you approach 4? So if this is 4, both sides of 4 are on -3. The answer to the limit is -3. My next one is a linear function. So visually you're thinking it's a line going through the origin with a slope of -3. All right, so for every 1 unit over, it's going 3 down. Here's a quick little visual of the graph. My job is to find this missing value. At 4, what is the approach? Well, you simply take 4, plug it into the linear function, so then I can say this value is -12. So the answer to my limit is -12. For some graphs in the homework, which eventually you will get to, you are going to use your pre-calc skills to sketch the graph. And once you have the graph sketched, then we'll evaluate the limits. So I have already put the graph up here because these are pre-calc skills. If you're having trouble, then you might want to review how to draw these particular trig functions before starting school. Here we go. We have h of x, our piecewise function, and we're approaching pi over 2, but from the right. So visually I can see right of pi over 2 is here, and I'm going to head towards pi over 2 coming from the right. That gets me a height of 1. Another way to do it for an analytic approach is go up here to the piecewise defined function. To the right of pi over 2 would be bigger than pi over 2. So that means I want to go back to the function, plug in pi over 2, which would yield 0, and cosine of 0 is 1. Then I want to approach pi over 2 from the left. If I approach it from the left, here's pi over 2. Left of pi over 2 is this curve. If I notice I'm approaching from the left, I have a height of 0. Graphically, if I wanted to do it analytically, negative for pi over 2 coming from the left would be less than pi over 2. So I'm going to plug pi over 2 into my function. Sine at pi over 2 is 1. 1 minus 1 gives me that answer of 0. Last and final piece is what's happening as we approach just pi over 2. This means both sides, and both sides have to approach the same height. We can clearly see both sides are not approaching the same height. This does not exist. And that's it for our intro.